Assalamu alaikum everyone. Today we will be covering the first lecture on the topic probability generating function of further statistics of Cambridge further maths. In this topic we will have to cover, according to the syllabus, we have to cover these things, understand the concept of probability generating function, that is popularly known as PGF, and construct the use of the PGF for given distributions. Then secondly, use formula to find the mean and variance of a discrete random variable in terms of its PGF, and use this formula to calculate the mean and variance of a given probability distribution. And the last one is use the result that PGF of the sum independent random variables is the product of the PGFs of those random variables. So we will do one by one. First of all, we will write down some facts about the PGF. On the screen you can see that every discrete random variable has a unique PGF, just like every human being has a unique fingerprint. So this is how we can understand the importance of PGF, that this is very easy to understand, that we have to remember that every discrete random variable has a unique PGF, just like every human being has a unique fingerprint. Next one is PGF allows us to extract probabilities by looking at the coefficients. Here you can see that the PGF is like this. So if I ask you what is the probability of x is equal to 0, then just look at the coefficient of t0. T to the power 0, that this is the probability of x is equal to 0. Now if I ask you what is the probability of x is equal to 1, then look at the term with t to the power 1. The coefficient of this is the probability of x is equal to 1, that means 0.5. Now if I ask you to find the probability of x is equal to 2, the probability of x is equal to 2, then what would be the value here? You have to look at the coefficient of the t squared term, that is 0.2. Next one is we have to know the uses of PGFs. On the screen you can see that PGFs give an elegant and efficient way of finding expected values and variances. It gives a concise form for a probability distribution function and allows much greater analysis. The third one is by recognizing the expansions and functions, the PGFs enable us to describe the structure of infinite discrete distributions such as the Poisson distribution and geometric distribution. Very important points, guys. Now we have to understand that we can therefore use PGFs to find probabilities when the value of the discrete random variable is large. So these are the uses of PGFs. Probability generating function. Now lesson objectives. What is our objective here? First of all, we need to know how to define a PGF. Then the second point is obtain a PGF from a probability distribution. We have to understand that how to obtain a PGF from a probability distribution. Then the next one is we have to understand how to use the PGF to find mean, variance and probability. Then use PGFs for sums of independent random variables. So these are the lesson objectives of this topic. Next one is formulae. Which formulae should we cover? For a discrete random variable x taking non-negative integer values, we have to know that this is the probability generating function gxt is equal to e of the t to the power x. That means we need to understand that this is actually t to the power k into probabilities from k is equal to 0 to infinity. This is the formula with which we will generate the probability generating function. Properties. G of x, gx, probability generating function, gx of 1, it is actually 1. Then e of x is equal to g prime x1. G prime, you understand that this is the first derivative of the probability generating function. Now, next one is var x. How to get that? Second derivative of gx at x is at 1, first derivative of gx at x1, and then first derivative of x at 1 whole square. This is how we get the variance. So these are the formula that would be given in the booklet, so you don't need to worry about that. Now next one is, we have to understand, or we have to write down what are the standard PGFs for a binomial distribution, a Poisson distribution, and a geometric distribution. So these are the formulae to get the probabilities, and these are the probability generating functions. Then the probability in a PGF can be found by using this formula. Probability of x is equal to r is equal to g to the power r t by r factorial. Then for two random variables x and y, we can find gx plus y t, that means the generating function for those two independent random variables is gxt into gyt. We have to multiply them. Generalized for three or more variables. That means if we have two variables, then this one. If we have more than two variables, then this is the generalized form. Just the generating function for variable x, generating function for variable y, multiply all of them. That's all. Then we have to know that this is called convolution theorem. The way we get the generating function for two or more random variables, it is called convolution theorem. Then PGF of a linear transformation. Gax plus b, this is a linear transformation of t to the power b, that means the constant would be the power of t, and gx t to the power a. So this is the formula with which we can get the PGF of a linear transformation. Now next one, we will directly enter to a sum, or we will directly deal with the sum to generate the probability generating function. I have taken a sum from the question paper, which is from summer 21. Tanji has a big bag containing 4 red balls and 2 blue balls. He selects 3 balls at random from the bag without replacement. The number of red balls selected by Tanji is denoted by x. Now you are asked to write down the probability generative function of x. So first of all, I have to understand what is x. X is number of red balls selected. So I have to understand that here, as we are selecting 3 balls, that means there is a possibility of getting 3 red balls or 2 red balls or 1 red balls. Then what would be the outcomes look like? What would be the outcomes here? That means 3 are red, red, red. Then 2 red, 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 red prime. 1 red, red, red prime, red prime. So here we can get the values of x. What is x here? How many red balls we have? That means here the value of x is 3, 2 and 1. So how to get the probabilities? We have 4 red balls and total 6 balls, and from there I need to take 3. So from 4 red balls, if I select 3 balls, it will be 4c3, and what would be the total? 6c3. So I have to divide that one. Now here when I am getting 2 red balls, that means out of 4 I am taking 2 red balls, so it will be 4c2 at the numerator, and total is 6c3. Now when I will take 1 red ball, that means I am taking 1 red ball out of 4 red balls available, so 4c1, and before that one, I must say that when you are taking 2 red balls, it is 4c2, and you need 1 ball that will be taken from non-red, that means the 2 blue balls, so 2c1 for that one, for the third ball, so and divided by 6c3. When you will be taking 1 red ball, that means out of 4 you are taking 1, 4c1, and out of 2 blue you are taking 2, so 2c2 divided by 6c3. So this is the general concept of permutation and combination. Now if you use your calculator, you will get the values like 1 by 5 and then 3 by 5 and then 1 by 5. So these are the values that we can get from here. Now here we can get the generating functions formula as we just wrote it down. Then if I apply this formula, I can easily write that here I have to take the probability and then t to the power k. So when 1 by 5 is the probability here and t to the power 1. Now 3 by 5 t to the power 2 and then t 1 by 5 t cube. So this is the probability generating function. If I first of all I have to get the probabilities and then I will have to apply this formula to get the probability generating function. So this is how we do that, guys. Now next one, in the next type of sum, it is also taken from the question paper of May June 21, and here we will try to understand how we can get the probability generating function Ex and also var x. For the Ex we know that this is the formula, and for the var x we know that this is the formula. Now to find Ex we need to get the first derivative of gx. So if I get the first derivative of gx, what is the value here? Whole squared, and at the denominator you will get 4t. So this is the first derivative. Now I need to know the value of the first derivative at x is equal to, at t is equal to 1. So g prime 1 is equal to 4 into 1 by 3 minus 2 into 1 squared, that is 4. So this is the value of Ex. Now what would be the var x? For var x I need the second derivative. So how to get the second derivative? Just differentiating the first derivative. So if I do the differentiation by using the quotient rule, that's all, and then you get the value here. We are getting, this is the expression for second derivative, and when we are having the second derivative, get the value of the second derivative at t is equal to 1, and you will apply the formula to get the var x after getting the second derivative at t is equal to 1. So at t is equal to 1, if I put t is equal to 1 here, 12 plus 24 divided by 3 minus 2 whole cube is equal to 36. So I have got the second derivative at t is equal to 1, I have got the first derivative at t is equal to 1 of the probability generating function. So we can say that Ex is equal to 4, and now we can get the value of the var x. So let us find that. Var x is equal to second derivative at t is equal to 1 plus first derivative at t is equal to 1 minus first derivative at t is equal to 1 whole squared. Now you just put the values here. So this is the value 24. Now the last part of this sum is very interesting, that you are asked to find the probability of x is equal to 4 by using the probability generating function. This is the probability generating function. Now if I ask you to write down the gx properly in the proper expressions that you have, is like this: k is equal to 0 to infinity. Now if I put k is equal to 0, that means probability of x is equal to 0 to t to the power 0 into t to the power 0. So x is equal to 0 is the value, and we can get the expansions from there. Now this is the probability generating function given. Now if I expand it by using the concept of binomial expansion, what will I get? I will get different terms of the probability generating function. Then I'll have to look at the term where you have t to the power 4, because you are asked to find probability of x is equal to 4. And from the previous concepts we know that in the probability generating functions, the power of t is the probability of x is equal to that value. If the power of t is 4, that means the coefficient of that term would be the probability of x is equal to 4. Now I have to expand this by using the concept of binomial expansion. So let us do that, guys. First of all, I have to make the first term 1. Now if I expand it by using the concept of binomial expansion, I'm getting this. You don't need to expand and simplify all the terms, because you are only concerned about the term where you have t to the power 4. Now here you can see that this is the term where I'm getting t to the power 4. So I am actually concerned about the coefficient of this value, of this term. So if I multiply 1 by 3 with this term, I'm getting, use your calculator guys to get this value, I'm getting 1 by 3 into 1 by, this is 1, and then 4 by 9. So this is actually the probability of x is equal to 4. So this is how we can get the probability of any value of the random variable by using the probability generating function. This just simply expand them by using the concept of binomial expansion and look for the exact coefficient. That's all. So this is all about today's lecture, guys. Thank you very much. Assalamu alaikum.